Okay, YouTube, in my last video here over quadratics, what we'll discuss is how to write the standard form of an equation of a parabola, given that we already know its vertex value, and then some point we could say x and y on the graph. So long as we know x and y, and I'll point this out, recall that if it's in standard form, that is, we say it's in this form, a times the quantity x minus h, quantity squared plus k. If we know the vertex, which lies at hk, so this would be the point h comma k here, then what we could do is we could go write its equation just by plugging in known values, which are hk, x, and y. Look at this. I mean, we have y, we have h, we have k, and we have an x. Okay, we have x, y, h, and k. The only thing we won't know when we plug in all these values will be this value of a. So to go find the equation here, essentially what you're going to do is just substitute all the values in and solve for the unknown a value. So maybe we'll make a note here. We say, okay, to find the equation in standard form for a quadratic function, one, we must know the vertex value and at least one point xy on the graph. Okay. And we say the vertex value, we say I'll go values since it's plural, we need to know h comma k. And so what we'll do is after we know those, we could say substitute in all known values, and then 3 will be solve for the unknown value, which is going to be the a value. And then step 4 we'll talk about, we'll just rewrite the equation with x and y in place of the values that we used when we substituted. Boom. Okay, so let me get my pen tool back out here. We'll talk about what we need to do. So essentially what I'm mentioning here is this. We already know y, we already know an x, we already know an h, we already know a k. So to rewrite this, what it's going to look like is this. We have y equals some a that we don't know, times x minus h quantity squared plus k. So in this instance, we say, well, the vertex hk, we already know that h has a value of -4. So I'm going to go plug that in. We say -4, and k has a value of 11, so we'll throw that in here. In terms of some x and y, well, they told us the point -6 comma 15 is on this graph. So our y value would be equal to 15 if and only if x is at the time equal to -6. So you can see how this will all just reduce for us here. We'd say, well, then we would have 15 equals a times. Now, using the order of operations, I think we need to simplify in our parentheses first here. And we get -6 plus a +4 would be a -2. So simplifying this further, we would say that 15 equals a times -2 squared, which is 4, plus 11. And booting this constant term over to the left side, we get 15 minus 11. This is going to give us 4 equals 4a. And so it follows that a is equal to 1. So in this instance, now that we know a is 1, so we substitute in all known values, we solve for the unknown a value. What we're going to do is rewrite this equation with just a plain old general x and y in place of these values that we put in the first place. So instead of putting -6 for x and 15 for y, what we're going to do is we're going to go back and just replace those with x and y in general. And so our new equation would look like this. We'd say, well, then just y is equal to our a value, which we came up to be, have a value of 1 here, times just x minus now a -4. So that came out to be a plus a +4, which looks like this. And then we'd say plus 11. And so looking at this, we'd say x plus 4 squared plus 11. What if we were to go take a look at the graph of this? So we'd say we have a vertex of -4, 11. We can actually go and verify that right now. And does it go to the point -6 comma 15? So let's go graph this. We have x plus 4. We could say, let's do a new graph here. New. Desmos. Okay. We'll throw this into projector mode, but we have f of x equals the quantity x plus 4, quantity squared, plus 11. And so I'm going to need to zoom out a little bit here. But we can see that the vertex does indeed lie at -4, 11. And in terms of the point that we claimed to be on this graph in the first place, we said, well, when x is -6, we believe that the y value is 15. So if I were to go left 6, we should have to go up 15 to hit our graph here. And I certainly see this, and we can actually even ask, we say f of -6. What is our function value at -6? it says that that value is indeed 16. So we could have used any points on this graph, but that was the one we were given on this graph, and we were given the vertex value. So to write the standard form equation, basically you go plug in everything you know and go solve for the one thing we don't know, which is going to be this a value, and then go back and rewrite it again, placing in the given h and k because we know the vertex is there, and then substituting now the known a value while leaving x and y general. Cheers.